In this class, we learn more about blockchain as a data structure. Blockchain as a data structure is one core concept of how we can create a system of money in the form of digital tokens. We will introduce the blockchain data structure in 3 steps, starting with how the cash register is used when paying with one bank account money, 2 physical coins, and finally 3 digital coins. Recall that Mr. Riddy has his cash register and he wants to register a sale transaction for a whiskey, wine, or a cigar in exchange for receiving digital coins from the customer. He has a fresh brand new cash register with nothing inside, no cash and not even page receipts. The wine enters as an output in his cash register that needs to balance with an input of money. Let's move to understand what happens in the cash register when different forms of payment are used, starting with the most common form of payment, that is bank account money. 1. Paying Mr. Riddy with bank account money. If the customer pays with bank account money, when he receives his notification from his bank, then Mr. Riddy is happy. The account manager takes care that the account money has safely arrived in the bank account he owns. 2. Paying Mr. Riddy with physical cash. If the customer pays with physical cash, the transfer of possession of these physical coins would satisfy Mr. Riddy that this input matches the customer taking a bottle of wine from his shop. The word to pay in English comes from Latin pax or pace, that is peace, and appease or make happy. With physical cash, there is no appeasing, soothing message from his bank. Riddy would be happy and appeased knowing that he was paid when the paper notes or physical coins are handed over into his hands. Possession of the coins in his hands makes him the effective owner. Whether he is also the rightful legal owner matters less with possession of physical items like cash that are anonymous, which do not easily allow one to check the history of ownership called provenance. After getting the coins into his physical possession, his job is not done. He would not be paid or appeased and happy if one problem occurred called double spending. The customer could have copied a genuine paper notes or coin into 2 and spent it twice. Getting the fake note or coin would be a problem for Riddy as he could do zero spending when others reject the fake coin Riddy received. Double spending is not just a problem, but it is also a financial fraud, meaning the intentional deception or fooling of Riddy being a forgery, i.e. the imitation of an authentic object. To be appeased and paid, Riddy would check the authenticity of the physical coins themselves by checking the anti-counterfeit measures on the coins, such as the milling and reading on the coin sides, or in case of paper cash, which has higher value denominations, the holograms, metameric ink shifting colors, intaglio prints, strips, micro prints, and watermarks. 3. Paying Mr. Riddy with digital coins. The customer, however, pays Mr. Riddy with digital coins, not physical coins. Again, because this is not an account CBDC, there is no message from the commercial or central bank. What does Mr. Riddy have to do to be paid and feel appeased and happy? First, check possession. The coin is not physically in his possession. Instead, it is the possession of a password key that defines Riddy's ownership of the digital coins. Password keys need to be secret to be exclusive possession. This is accomplished by asymmetric cryptography, also called public key cryptography, that allows us to create digital key passwords and addresses. One could be in the possession of a coin if someone has received a transfer from someone else, or in the case of Bitcoin, the person has mined a coin. The transfer of the ownership of the digital coin occurs when the current owner signs with their private key, a transaction that assigns the coin to another public key. That new owner in turn can transfer the ownership again to yet a third person by signing again a new transaction, and so on. Second, check double spending. To check the authenticity of the coin, we need to check double spending. This means authenticating the coin. Let's first remind ourselves how that is done with a physical coin. We check the object and do not need to know provenance or history of possession. The last step in history is sufficient. You can often see winners at the Olympic Games biting their medal. This part of the pageantry may be a remnant of the past where people checked gold in this fashion. As an aside, gold, especially pure 24 karats gold, is a very soft and malleable metal that may be dented with teeth. If the metal is only gold-plated, as is the case today, or alloyed with lesser metals, it may be hard and not leave any dents. When authenticating the physical coin, we only check the last step in the history of transactions, i.e. the coin that was handed to Mr. Ritty. However, for a digital coin, we need to check the whole history of all past transactions, which in the case of Bitcoin is the history of all the digital signatures, i.e. the signed transactions associated with this coin, all the way back to its origin and issuance. That is why Nakamoto says that an electronic coin is a chain of digital signatures. Nakamoto 28. So we need to know provenance, history of past transfers of possession. But we said Ritty has a brand new cash register without any pages inside. Ritty does not know who owns what coins. Fortunately, he is not the only show owner in town. Several people, let's call them 80, Bitty and City ABC, have adopted his invention of the cash register. To find out what is the latest status of ownership of digital coins, he talks with the other cash registers in his town. Let's suppose that Ritty will first just talk to 80 and download their sequence of pages. Ritty sees that the customer who is trying to pay him with a digital coin received that coin from another person, which in turn received it from another person, and so on, like a hot potato being passed around. When he downloads all the pages from 80, what is on each page? There is a page number referring to the previous page, and some entries like the input, who the coin came from, an output, who the coin went to, and the digital signatures of sender, as well as the address of both the sender and receiver. But this doesn't complete the check to prevent double spending. What if the customer already spent his coin at another CR like at Bitty or City? For ensuring the coin is not already spent, Ritty also needs to download all the pages from A, B, and C. These are a bunch of digital pages. It would be hard to manually check each digital file of pages for errors to ensure integrity of the data on each page across all CRs. To efficiently ensure data integrity, i.e. to easily check that each and every page is distributed in identical copies across the CRs, the blockchain transforms the sequence of pages into a chain of blocks. Instead of just numbering each page with a page number to merely order the pages, the blockchain adds a cryptographic page reference on each page that does two things. First, it refers to the previous page, and second, by summarizing the contents of the previous page with a digital fingerprint called a hash, from a cryptographically secure hash function. Because all pages are now not just ordered as a sequence, but actually form a chain, we only need to check the single cryptographic page number or reference on the one page, that is the very latest page, to ensure that a CR has the whole history of pages, and importantly, that the content of that chain of pages is identical to any other copy at another CR machine. Otherwise, the chain would be broken. Here, ladies and gentlemen, have we the first meaning of blockchain. Blockchain is a specific data structure that enables efficient checking of data integrity. The data is structured in a blockchain, a cryptographically chain-linked list of transactions recorded on page blocks. Blockchain does not make data immutable and does not make data tampering resistant, just tampering obvious, i.e. change sensitive. This way, Mr. Ritty can check the consistency of all the pages downloaded from the other CRs by just downloading it once and then comparing the pages received from 80 CR and asking for them cryptographic hash page number of the last page from Bitty's and City's CR. This helps to know that the coin hasn't been spent already. As receives the coin from his customer, Mr. Ritty prints a new page or block and chains it to the existing chain and sends that new block to any other CR. Now that we learned what and why to use blockchain as a data structure in building a distributed digital cash system, in our next and last class, we will learn about blockchain as a consensus mechanism.